Welcome pre-cal students to the homework help video, page 70, 39 through 45 odd, 57 through 63 odd, and 71 through 78 all, and also 79 through 85 odd. Let's start off with numbers 39 through 45. The directions say to simply find the distance between the ordered pairs and give an exact answer or round to 3 decimal places. So let's go ahead and get started. We're going to do the first 8 problems, these 4 and the next 4 very quickly because they are simple problems, and we'll focus most of our attention on the last 12 problems. Okay, the distance formula would be this right here. And then of course we should know by now it's x minus x quantity squared plus y minus y quantity squared. So x minus x, 4 minus 5 would be a negative 1 squared. Y minus y would be 6 minus 9, negative 3 quantity squared. If you square a negative 1, that's a 1. If you square a negative 3, that's a 9. And 1 plus 9 would be square root of 10. Which when you type that into your calculator and round to 3 decimal places, you get 3.162. On a test or a quiz, I would accept either one of those 2 answers. All right, number 41. Distance formula is the square root of x minus x. 6 minus 9 is negative 3 quantity squared, plus y minus y would be negative 1 minus 5, negative 6 squared. When you square a negative 3, you get a 9. When you square a negative 6, you get a 36. So you end up with the square root of 45 for number 41. Now I would really like you to learn how to reduce these, or at least to review. 9 times 5 is the same thing as 45, and you know the square root of 9, so you cross off the 9 and put a 3 on the outside. So if you're going to leave your answer in radical form, I would like it like this. If you're going to type into your calculator and round to 3 decimal places, you will get 6.708. Now, you could have typed this into your calculator and you would get this, or you could type this into your calculator and you'll still get the same answer. Either one works. All right, number 43. X minus x, negative 4.2 minus 2.1 would be a negative 6.3, and of course that's squared, plus, and then y minus y would be 3 minus a negative 6.4, that's a positive 9.4 squared. When you square 6.3, or a negative 6.3, you come up with 39.69. And when you square 9.4, you come up with 88.36. Now if you add those 2 numbers together, you will come up with the square root of 128.05, and then we're going to take the square root of that, and you will come up with 11.316. 11.316. All right, that's number 43. And then number 45. Let's find the distance between those 2 points. Negative 1/2 minus 5 halves would give you a negative 3. Use a calculator if you need to on that. Negative 3 plus, and 4 minus 4 would be 0 squared. When you square a negative 3, you get 9. When you square a 0, you get 0. 9 plus 0 is 9. And the square root of 9 would be 3. So the distance between these 2 points here would be 3. All right, let's move on to the next 4 problems. And the directions for the next 4 problems are simply going to say find the midpoint. So the next 4 problems will go pretty quick, 57, 59, 61, and 63. And we're going to find the midpoint between 2 given points. Okay, I'm not going to write the formula over and over. I'll write it one time. Remember, in order to find the midpoint, you add the 2 x's together and divide by 2. Then you put a comma, then you add your 2 y's together and you divide by 2. And that will be the ordered pair that falls right in the middle between these 2 ordered pairs. So we're finding the midpoint, or the point that lies between 2 given points. So here we go. X plus x, 4 plus a negative 12 is a negative 8. Always put it over 2. Negative 9 plus a negative 3 would be negative 12 over 2. And so your final answer would be negative 4, comma, negative 6. Now, if you ever want to check your answer, you can plot all three of those points, this point, this point, and this point, and negative 4 and negative 6 should fall in the middle. Let's take a look at number 59. X plus x over 2 would give you 9.9 over 2, and then y plus y over 2 would give you negative 9.9 over 2. And then if you type that into your calculator correctly, you will come up with 4.95 and negative 4.95. Okay, so these numbers right here, this ordered pair, these two numbers, they make up the midpoint, or the point that falls between these 2 points right here. Okay, let's continue on. Take a look at number 61. If you add your two x's, you will get negative 12 over 2, comma. If you add your two y's, you will get 13 over 2. So your final answer is negative 6, comma, negative, or not negative, that would be positive, so negative 6, comma, 6 1/2, or 6.5. All right, moving on to the last problem in this section, and then we'll get to the harder problems. Negative 1/6 plus negative 2/3 would give you negative 5/6 when you add those two together. So negative 5/6 all over 2. Now let me show you where I got negative 5/6. That's x plus x. So a negative 1/6 plus a negative 2/3 would be a negative 5/6. Okay, moving on to the y plus y, we have a negative 3/5 plus 5/4. If you add these two numbers together correctly, negative 3/5 plus 5/4, you will get a positive 11/12. And again, if you struggle with fractions, use your ABC button on your calculator, or your fraction button on your calculator. And now, negative 5/6 divided by 2 would be the same thing as negative 5/12. And if you take 11/12 divided by 2, you will get 11, let's see. Okay, students, I'm back, and I do apologize. You understand when you're making a video, little mistakes happen. The math I've taught you is correct. However, when I typed in negative 3/5 plus 5/4, I got 11/12. And I think what I typed in was 1/3 instead of negative 3/5. I don't know why I would do that. But let me try this again. Negative 3/5 plus 5/4. And this time I'm getting 13 over 20. So if that's what you had before, I apologize for confusing you, but little mistakes do happen. And now 13/20 divided by 2. You can do this longhand like this. 13 over 20 divided by 2 over 1. Or you can flip that fraction and multiply. Or you can type this whole thing into your calculator. 13/20 over 2. Either way, you'll get the correct answer, which is 13 over 40ths. Okay, 13/40. All right, let's continue on now to the more difficult problems. The first 4 problems that we did today, we were finding the distance between 2 points. And these last 4 problems, we were finding the midpoint between 2 given points. Now we're going to get into the more difficult problems, and that's dealing with circles. Okay, starting with number 71, the directions say to find an equation of the circle that satisfies these conditions. Now, what I taught you during your notes is anytime you're asked to find or write the equation of a circle, you must have the center and you must have the radius. Well, the first problem, usually most books start off with the easier problems and then work up to the more difficult problems, and that's the case here. You're actually given a pretty easy problem here. They give you the center and they give you the radius, so we should know what to do. It's a positive 2 right here for your x value, so you write in a negative 2. We change the sign and then close the parentheses squared, plus, and then your y value is 3, so I'm going to change the sign of 3 and put a negative 3 squared equals and then your radius is 5/3. Now because it's a fraction, I'm going to put parentheses around it. And remember, you always square the radius. Now think about it. If I would have written it like this, 5/3 squared without parentheses, you would have thought that just the 5 was being squared. And that's why I put the 5/3 in parentheses, okay? So there you go. There's the answer, or there's the equation that satisfies the given information. Now, probably on a test or quiz, to be honest with you, I would like you to go ahead and simplify this right side over here. So 5/3 squared means 5/3 times 5/3, and that would be 25/9. So there you go. There's the equation of the circle that satisfies these conditions. Okay, now let's think about something here for a second. I know we're going back to many years ago, and I don't want to insult your intelligence, but this is pretty simple. We should know by now that when you have a circle, whenever a line runs from the center to the edge of the circle, that's a radius. And whenever a line runs from the edge of the circle through the center, all the way from one edge of the circle to the other edge, passing through the center, we call that a diameter. Notice the diameter is always going to be twice as big as the radius. So this is my diameter right here. This is my radius right here. A diameter is always twice as big as a radius, okay? So with that in mind, let's go ahead now and apply that to this problem. In number 72, they're asking us to write the equation of a circle. Well, I've taught you over and over what two things do you always need. You need the center, we have that right here, and you need the radius. Now, they did not give us the radius, so I'm going to have to find the radius. They did give us the diameter. And the diameter of a circle is 8.2. Now, if a diameter is twice as big as a radius, if I cut this in half, the diameter that is, then I will have the radius. So 8.2 divided by 2 is 4.1. So now I do have the center and I do have the radius. As soon as I have those two bits of information, I'm ready to write my equation. Notice I have a positive 4 here for my x value, so I'm going to change the sign and put x negative 4 squared plus. Notice I have 5 for my y value. I'm going to change the sign. Y minus 5 quantity squared equals, and now my radius is 4.1. So I'm going to put 4.1 squared. Now on a test or a quiz, I would like you to simplify the right side if at all possible. So 4.1 squared would end up being 16.81. 16.81. And there you go. There's the equation of the circle that satisfies these requirements up here. All right, number 73. Let me go out and grab a quick drink here. Now on this problem here, it might be beneficial to get a quick picture of this circle and just kind of understand what we're dealing with. That's my suggestion to you on this one. Now they do give us the center, so we're good there, but they don't give us the radius. Now let's think about this for a second. I'm going to very quickly just sketch the circle. The center is at -1, +4. So there we go. That's easy enough. And then the circle has this center, -1, 4, and the circle passes through this point right here, 3, 3, 7, which is right here. So this is the center, right here. This is the center, and the circle passes through this point right here. So now would y'all please think about this for a second? I know my circle is not the best. It looks pretty, not drawn to scale very well, but we can still understand this is the center right here, and this is a point that lies on the circle. How do I know that? Because it says it right here. Here's the center of your circle, and then it says the circle passes through 3, 7. So this is on the circle, this is the center, this is the radius right here. Well, all that I have to do is find the distance from this point to this point. Hold it. Didn't we just learn that earlier in this lesson today? We learned how to find the distance between 2 points, didn't we? And I taught you the distance or the length between 2 points is found by using this formula right here. X minus x, quantity squared, plus y minus y quantity squared. So if I want to find the distance or the length of this line or the distance between these 2 points, then I use my distance formula. And this point right here is negative 1, 4, and this point right here is 3, 7. So here we go. We can find the distance or the length of this line very quickly. So let's see, negative 1 minus 3 would give you a negative 4 squared. That's from subtracting your 2 x's. If you subtract your 2 y's, 4 minus 7, you will get a negative 3 squared. If you square a negative 14, you get a 16. If you square a negative 3, you get a 9. If you add those two together, you will get 25. And if you take the square root of that, you will get 5. So there, we found the length of this line. The length of this line from here to here is 5. Is not that your radius? That's the radius of the circle. Here's the center of the circle. Here's a point that lies on the circle. So this is the radius of the circle. So we just found the radius. So now we do know the center of the circle, and we do know the radius of the circle. And the radius, as we just saw, is 5. That's a pretty tough problem, but that's how you would do that. So my x value is negative 1. I'm going to change the sign and write a positive 1. X plus 1 squared plus, and then y, I have a positive 4, so I'm going to change the sign and put a negative 4, quantity squared equals, and then you always write your radius squared, okay? And of course I'd like you to simplify that, so a radius squared, 5 squared, would be the same thing as 25, alright? So 5 squared is 25. So that's how you would do 73. They're going to get harder as we go along. They're going to make you think more and more outside the box, making you think, how do I find the center and how do I find the radius of these different problems. Alright, number 74. Well, this is going to be identical to the last problem. If we go back a page and look, they gave us the center and they told us the circle passed through this point. In order to solve that problem, we found the distance from the center to this point here. And that's what we did in this problem, right? We found the distance from the center to a point on the circle, and of course the distance from the center to a point on a circle is always the radius. So we'll do the exact same thing in this problem, okay? Here's the center of the circle right here. There's the center. And this point right here, 1, 7, lies on the circle. So we're going to find the distance between these 2 points, and that will give us the radius. So here we go. The distance would be x minus x, 6 minus 1 is 5, so 5 squared, plus, and then y minus y, negative 5 minus 7, is negative 12 quantity squared. 5 times 5 is 25. 12 times 12 is 144. When you add those two numbers together, you will get 169, and then the square root of 169 is 13. So there, you found the radius. The distance from the center of the circle to a point on the circle is always the radius, and the radius is 13. So now we know what the center of the circle is. That was given to us in the original problem, and now we know what the radius is of the circle. So we can write our equation. So here we go. X minus 6 quantity squared plus y plus 5 quantity squared equals, and then my radius is 13, and you always write the power or the radius with the power of 2. Alright, so 13 squared. Of course, I would like you to simplify that on tests and quizzes and just go ahead and put 169. Alright, moving on to number 75. Let me get a drink here. Okay, in this problem here, maybe we should get a quick picture of it. The points 7, 13 and negative 3, 11 are at the endpoints of a diameter. So in other words, you have a circle, and we'll just pretend that this ordered pair right here, negative 3, 11, is right here, and we're going to pretend that this point here, 7, 13, is over here. And here's the center right in the middle, and we're going to draw this line. Now that's exactly what this says that we have. Read it carefully. The points 7, 13 and negative 3, this should be a negative here, negative 3, negative 11, are at the ends of a diameter. So this is a diameter right here. and these are the ends of it. Drawing a picture like this does not help you so much see what to do. I do not know what the center is, and I do not know what the radius is. But now that I've showed this to you, is it not so easy to find out? I mean, look, to find the center, I need to find the what? Wouldn't it be the midpoint? Is not the center going to be right in the middle of these two endpoints right here? Sure it is. So in order to find the center, I'm going to find the midpoint. And then in order to find the radius, I'm going to find the distance of this whole line right here and then divide it by 2. So to find the radius, I'm going to find the distance of this whole line from this point to this point, and then I'm going to divide it by 2. So there we go. There's my two formulas I'm going to use, or the two methods I'm going to use. Let's go ahead and get started. First of all, let's find the midpoint or the center. Well, I'm going to find the midpoint of these two ordered pairs. So x plus x would be 4 over 2, comma, and then y plus y would be 2 over 2, comma. So my midpoint would then be 2, comma, 1. So the midpoint between these two endpoints is 2, 1, and that's going to be my center. So just like that, I was able to find the center. Now let's go ahead and find the distance between these 2 points. Of course, we'll use the distance formula. And so 7 minus a negative 3 would be 10 squared, plus 13 minus a negative 11 would be 24 squared, and 10 squared would be 100, and 24 squared would be 576. When you add those two together, you will get 676. And when you take the square root of 676, you will get 26. Now hold on, that's not your radius. Remember, that's the distance all the way across the circle from this endpoint to this endpoint, okay? So what we have to do then is we have to divide that by 2, which to cut it in half, a diameter is 26, so the radius would be 13. So there, just like that, without too much of a problem, I have now found the center of the circle and I have found the radius right here of the circle. So now write your equation. You have a positive 2 for your x value, so you're going to write x negative 2. You're going to change the sign. We always put a plus sign here. Your y value is 1. I'm going to change the the positive 1 to a negative 1. And then over here I'm going to write 13 squared. The radius is 13, and we always square the radius. And of course, on a test or a quiz, I want you to go ahead and simplify that and put 169. Okay, so not too bad. Let's move on now to number 76. Alright, number 76 is a little more of a challenge. Let's see if we can't figure this out. They give us 4 points, and they tell us these 4 points are vertices of an inscribed square. Now, first of all, if you have forgotten from geometry, or if you've not had that class yet, what inscribed square is, key phrase there, inscribed, means the square is inside the circle, and it's inside the circle in such a way that the vertices, or in other words, the corners, if you want to use a different word, the vertices or the corners of the square lie on the edge of a circle. So what I just drew right here is an example of a circle that has an inscribed square. So when it says inscribed square, it means there's a square inside of a circle. Okay, so let's go ahead and draw that so we can get a picture of it and understand what we're dealing with. So I am going to probably have to erase everything I'm about ready to do so we have space on here to work out the problem. So if you want to write this down, that would probably not be a bad idea to do. Okay, the first order pair is negative 9, 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and up 4. 1, 2, 3, 4. So this ordered pair right here is one corner of my square. Another one is negative 2, 5. So over 2 and up to 5. Next vertice, or the next vertex, which is singular for vertice, the next vertex is negative 8, and then down 3. So I go over to negative 8, which is right here, and then down 3. Then my other ordered pair is negative 1 and down 2. So I'm going to go ahead and just kind of lightly not really draw the square, just kind of sketch it, like kind of just put a quick little drawing here of the square. Now let's go ahead and also draw the circle around the square if at all possible. So the circle is going to look something like this, and of course my drawing is not going to be perfect, but it'll definitely give you the idea of what we're trying to do here. There we go. Not the best circle, but you get the idea. So I have a picture now of what they're talking about. I hope you're learning how drawing a picture of the description really helps a lot. Now I've taught you over and over, if you're going to write the equation of a circle, you need to have two things. You need to know what the center is, and you need to know what the radius is. Now, if we truly have a square, and we do have a square, and we draw the diagonals of the square, first of all, do you notice what I have right here? When I draw this diagonal, do you not see what I have? I have a line that goes from one edge of the circle to the other edge of the circle, and it has to be in the center of a square. It has to be, because when you draw two diagonals like this, they're always going to, of a square. It has to be a square. If you draw two diagonals of a square, these diagonals equal each other, and they're also going to bisect each other. And what that means is this diagonal right here that I'm drawing, this one right here that I did draw, it has to go right through the center of the circle, because the square is inscribed, which means it's in the center of the circle, and the center of the square is the same as the center of the circle. So what I have right here, what was this ordered pair right down here? It was -8, -3. -8, -3. And what's this ordered pair right here? -2, 5. Now, you say, Mr. Earhart, could have we drawn this diagonal here and used this point here and this point here? Yes, definitely, of course. You would get the exact same answer I'm going to get. I just chose to use the other diagonal. Nothing wrong with using the other diagonal. That's fine. So, do you see what I have? I have this line that goes from here to here, and we call that a what? It goes all the way through the circle, and it hits the circle on the edges and goes to the center. We call that a diameter. So these 2 points right here, this point and this point, are the endpoints of a diameter. So all that I have to do is find, if I find the midpoint right here, this is the midpoint right here. If I find the midpoint between these 2 points, that'll be my center. And if I find the whole length of this diameter from here all the way to here, and then divide it by 2, that will give me my radius. So the only 2 points I need out of all 4 of these, I'm going to circle them for you, would be this ordered pair right here, -8, -3, and this ordered pair right here. Now, could have you drawn the other diagonal and used the other 2 points? Yes, you could, most definitely. I'm going to use these 2 ordered pairs. Okay, first of all, let's find the center of the circle. So let's find the midpoint between those 2 points. So the midpoint would be x plus x. That would be -8, -2 plus -8. That's -10 over 10, comma. And then find the midpoint for the y's. We would have 5 plus -3. That's 2 over 2. So the center would be -5, comma 1. -5, comma 1. Now, let's go ahead and find the radius. So what I'm going to do is I'm going to find the distance between these 2 points right here that are circled. And when I find that distance, that'll be the whole diameter. And then I'll cut that in half, and that'll be the radius. So the distance is x minus x. -2 minus a -8 would be 6 squared, plus 5 minus a -3 would be 8 squared. So I would then end up with 36 plus 64, which would then give me the square root of 100, which would then give me 10. Now that 10 is not my radius, remember? That 10 is my diameter. Okay, so I cut that in half, and my radius will be 5. So now that I know what the radius is, and now that I know what the center is, I'm ready to write the equation of my circle. X, I have a -5 for my x value, so I'm going to put a +5. Plus, and then for my y value, it's a +1, so y minus 1 quantity squared equals, and then when you square the radius, 5 times 5, you get 25. And there we go. That was number 76, a very good thinking problem. Okay, let's take a look now at number 77. Number 77, they give us the center of the circle, and then they tell us the circle is tangent or touching the y-axis. So students, we can find this. I mean, again, get a picture of it. Don't try to do this just in your mind. Get a picture of it. So we know the center is at -2, and you can tell by my drawings. It doesn't have to be a perfect drawing. Just draw it quickly. There's the center of your circle, and then what does it say? It says the circle touches the y-axis. So if I'm going to draw a circle that's going to touch the y-axis, obviously it's going to have to touch right here because it's supposed to. Tangent means it touches, but it doesn't go through the circle more than once. So if I have a point right here, I can go straight across to this point here, and the circle is going to look like this. There we go. That's all I had to do. That's all that this meant. When it said tangent to the y-axis, and don't forget this is the y-axis, it just meant here's the center, and then draw a straight line over to the y-axis, and then that's going to be where the circle intersects. Now, can you think about this for a second, please? If this is -2, 3, and you go straight across to the right, what's this ordered pair right here called? Well, that's obviously 0, 3. 0, 3. Well, students, I don't need to use the distance formula to find the radius. If it's a perfectly horizontal line, I can just count the spaces. I mean, I'm going from here to here. That's 1, 2 spaces. And I go from here to here to here. So the radius has a length of 2. Now, if you don't like what I just did there and you want to use the distance formula, please feel free to, no problem. Using this point here and this point here, I'm going to find the distance, and that will give me the radius. So I would have x minus x, -2 minus 0 would be -2 squared, plus 3 minus 3 would be 0 squared. 2 times -2 times -2 is 4, plus 0. 0 squared is 0, 4 plus 0 is 4, and the square root of 4 is 2. So there's the distance. I found the radius. So I knew what the center was already. Now I know the radius is 2, and now that I know the center of the circle and the radius of the circle, I am ready to write my equation. My x value of my center is -2, so I'm going to put x plus 2, and then plus. The y value of the center is 3, so I'm going to change the sign and put y -3 squared equals 2 times 2 is 4. And of course, really you should probably write this first, but the radius always squared, and then when you simplify 2 squared, you'll put a 4 right here. Okay, and that's the answer to number 77. Let's go ahead and take a look at 78. Let me get a drink here. It's going to be the same basic problem, only now the circle is tangent to the x-axis. So again, I think it only takes a second to do this. I encourage you to get a picture of what the problem looks like. So +4 and -5. So here's the center of the circle, and we know the circle is tangent to the x-axis, which means I can draw a line going straight up to the x-axis, and that's my radius. And now with that bit of information, I can somewhat sketch the circle. It's not going to be perfect, but it'll definitely be sufficient. Alright, there's my circle. So notice if I take this point here, which is 4, -5, and this point here, which is 4, 0, and I find the distance between those 2 points, I'll have the radius. Find the distance between those 2 points, and I'll have the radius. Now you could just count up. You realize you're at 0 and you go down to -5, so you know the whole length is 5. Count if you want to. It's 1. I'll put little marks. It's 1, 2, 3, 4, and then 5. And if you don't like to use that method, then go ahead and use the distance formula. Nothing wrong with that. So the distance formula that gives you the distance between these 2 points would be x minus x, 4 minus 4, that's going to be 0 squared, plus y minus y, 0 minus a -5 is going to be 5 squared. 0 times 0 is 0, 5 times 5 is 25, 0 plus 25 is 25, and the square root of 25 is 5. So the distance from this point to this point is 5. So now I know my radius equals 5. So I know what my center is. That was given to me at the beginning of the problem, and I know what my radius is. I just found that, so I know what my radius is. So now you are definitely ready to write your equation. So your x value is 4, change the sign, x negative 4, quantity squared, plus your y value is negative 5, change the sign, so y positive 5, quantity squared equals radius squared, or 5 squared. And of course I would want you to simplify 5 squared and make 5 squared become 25. All right, so 5 squared becomes 25. And there we go. Moving on now to the last one, 79, 81, 83, and 85. In these problems, they want you to sketch a graph, okay? They want you to sketch a graph of the given equation. So just 4 left. We're almost done. Hang in there. And we're just about finished. Let me grab this slide here and slide it right here so we can use that. And here we go. Number 79. Now when you look at this, I want you to graph this. The first thing you notice is Mr. Earhart. It's not written in standard form at all. I don't know what the center is. Well, hold on. If I have just x squared, let me throw a thought at you real quick. Wouldn't that be the same thing as x plus 0 squared? Because what is x plus 0? X, and then x squared is x squared. And the same thing for y squared. You have a plus sign here, which is good. Plus sign here, which you have to have that. And then for y squared, could I not just put y plus 0 squared? Could I not do that? Sure I could. So x plus 0 is x, x squared. Y plus 0 is y, y squared. So when you rewrite the equation like that, it becomes very obvious the center of the circle is going to be at 0, 0. Now, notice this number here is 4. Remember I taught you have to rewrite this number with a power of 2. Well, how in the world can I write 4 as a power of 2? Well, obviously it's pretty simple. I mean, 4 is a perfect square, so 4 is the same thing as 2 squared. So if 4 equals 2 squared, then I can definitely put 2 squared in place of 4. So there, now I'm pretty much all set. I know the center of my circle is 0, 0. And if you want to change the signs and put negative 0, that's fine, but 0 is really neither negative or positive. It's just the boundary line between your positive and negative numbers. But either way, your center is 0, 0. And then, of course, your radius, after you've written this right side with the power of 2, whatever your base is, that's always going to be your radius. So I know my center is 0, 0. So I put a point right here, 0, 0. And then I know my radius is 2, so I know I go up 2, 1, 2, put a point there, go down 2 from the center, go to the right from the center, and go to the left from the center. And notice all the movements I did had lengths of 2. Alright, so there's the circle, and not too difficult. And let's move on now and look at the next problem. Okay, moving on now to number 81. Number 81. First of all, x squared can be rewritten as x plus 0, quantity squared, plus, and then y minus 3, quantity squared, equals, and then how could I rewrite 16 with the power of 2? Well, 16 is a perfect square, so it shouldn't be that hard. 16 is the same thing as 4 squared. So now I know the center of my circle is 0, comma, you always change the sign, so instead of negative 3, a positive 3, and then my radius is always going to be the base of my power of 2, and my base is a 4, so the radius is 4. So there we go. So my center is 0, 3, so I'm going to go to 0, 3, which is right here, 0, 3, and then I'm going to realize the radius is 4. So from this ordered pair I go over 4, I go up 4, to the left 4, and then down 4. And there we go. Now all that you have to do is just sketch the circle the best you can. I'm not going to take points off if your sketch is not perfect. It's not that big of a deal. If you have a compass and you want to use it to draw the circles, that's fine. You don't have to. And there's the graph of your circle. Pretty much for the most part. All right, let's go ahead now and move on to the next number, which would be, hold on one second please, not sure why my eraser is not working. There we go. Let's move on now to number 83. Number 83. Okay, well, this is pretty simple. I mean, you can see right here the center is +1, +5, and then 36 is a perfect square. So how do you write 36 with the power of 2? Well, 6 squared. So your radius is going to be 6. These are pretty simple. So you know your center is at 1, 5. So over 1, up 5. And then from that center, 1, 5, I have a radius of 6. So I'm going to go down 6, 1, 2, 3, 4, 5, 6. Go to the right 6, that would be over here. Go to the left 6, 1, 2, 3, 4, 5, 6. And then this part of the circle is going to be way up here where it's going to kind of let that go and just pretend that we have it. So it would hit up here, continue, and then come on over to this point here. And that's good enough, okay? So there we go. There's the center of the circle, and there's your radius of 6. By the way, you notice when I count 6, you put your pen or pencil in the middle, and you don't count that spot. You don't say 1, and then 2, and then 3. You put your pencil at the center, and then you count your first movement. So you say 1, 2, 3, 4, 5, 6. Okay. All right. Last problem, and we are finally officially done. So way to hang in there. And last problem, and I hope that these explanations have helped you a little bit with your math. Okay. Well, I mean, the center of this circle is obviously going to be -4, -5. And then how do you rewrite 9 with the power of 2? Well, 9 is a perfect square. So I'm going to write 3 squared, which gives me 9. And now since I've rewritten 9 as 3 squared, I can see that my radius is 3. So my center is -4, -5. So 1, 2, 3, 4, 1, 2, 3, 4, 5. There's my center. And then my radius is 3. So I'm going to go over 3. I'm going to go up 3, to the left 3, and then down 3. Okay? And with that in mind, I should be able to draw a pretty good circle. All right, pretty decent. And not bad for someone like myself who really can't draw, okay? Good enough. So there's the center of my circle, and my radius is 3 all the way around. Okay, I hope this homework help video has been a help to you. Call or email if you have any questions.